stress distribution diagram. Okay, so for this kind of question, we will be solving for different geometrical sections such as rectangular sections, triangular and circular sections. अब आपको यहाँ पर अभी जो डायग्राम दिखाई दे रहा है, that is a rectangular cross section, right? अब इसके लिए जो shear stress distribution diagram draw करते हैं, it will come in this manner here. Okay, and now अब यहाँ पर आपको the major things that you need to solve for this numerical is to find this Q max. Now what is this Q max here? Q max here signifies the maximum shear stress. So this Q max here is a maximum shear stress which is denoted by Q max and it will be equal to 1.5 times Q average. Okay, uska formula ye hai. If you have to find this. Now to find this Q average shear stress, Q average को हम average shear stress बोलते हैं, which is equal to shear force divided by area. The area of this cross section. Okay, shear force is denoted by S. अब जो भी यहाँ पर force दिया है, question पे दिया होते हैं ये, okay, that force divided by area. B and D cross section दिया होते हैं, तो वहाँ से लगाया तो you get area. So this will be the formula, basic formula. Okay. Now let us see the first numerical. A beam 120 mm wide and 200 mm deep is subjected to a shear force of 48 kN at a particular section. Calculate maximum shear stress and sketch shear stress distribution diagram across the section. Now पहले हमें जो भी given है उससे हमें पहले draw करना पड़ेगा section, उसके बाद जहाँ पर load लग रहा है वो draw करके then we need to find a shear stress, उसके बाद we need to find shear stress distribution diagram. Okay, so let us get started. So in this numerical, cross section of a beam is given, so it is given equal to 120 into 200 mm deep. So it is 120 and 200 mm deep. Okay, so from here to here it is 120 mm and its depth is 200 mm. Right, and for this it says that it is subjected to a shear force of 48 kN. So it is subjected to given in the question is it is subjected, it has a shear force which is denoted with symbol S here, is equal to 48 kN. And what else do we have? Then next we are asked to calculate maximum shear stress and sketch the shear stress distribution diagram across the section. So what do we have to find? We need to find maximum shear stress. Maximum shear stress, which is equals to Q max. This we need to find. Now what is the formula to find this maximum shear stress? It is equal to Q max is equals to 1.5 times Q average, AVG average, right? So this is the formula. Now how do we find Q AVG? So it will be equal to 1.5 times Q AVG is equals to shear force divided by area. So this is your Q max. Now from here, how much is shear force given? Shear force is given 48 kilonewton. Now if we convert this into Newton, we'll get 1.5 times 48 into 10 raised to power 3. I have converted this to Newton now. Divided by, what is the area of this section? This beam section, it is equal to 120 into 200. 120 into 200. So from here I get equal to 3 Newton per mm square. So this is the maximum shear stress. Now we have to draw the shear stress distribution diagram. So how do we draw? It is simple. It should be at the same length here, from here also, right? And from here you draw a line, parabolic line. So you'll have a maximum shear stress at this point, right? So you'll have Q max here, which came equal to 3 Newton per mm square. So this is very simple. This one here is a neutral axis line. So I hope this numerical is clear. It is very simple. Let us solve the second numerical. A beam carries an UDL of 20 kN per meter over the entire span of 8 meter. Beam had rectangular section of width 230 mm and depth 350 mm. Determine maximum shear stress at a section 1 meter from the support. So let us get started with this numerical also. Now let us solve the second numerical. For this second numerical, it says it is a beam and it carries a UDL of 20 kN meter. So it is a simply supported beam and it carries a UDL of 20 kN per meter. So let this be A and B, okay? And the span of this beam is 8 meters. Beam has rectangular section of width 230 mm into 350 mm depth. So beam has a cross section of width 230 mm and its depth is equal to 350 mm. So we need to determine maximum shear stress at a section 1 meter from the support. Okay, so 1 meter from the support. This is, let this be support, right? And from 1 meter, this be 1 meter. So at this point I need to find a maximum shear stress. Okay, so how do we find? So let us start. The formula to find maximum shear stress is Q max is equals to 1.5 times Q average. This is the formula, right? Now from here, Q average is equals to shear force divided by area. This is the formula. Now we can find the area from this given cross section of this beam, but is the shear force given? Shear force is not given. Shear force S is not given, so shear force S will be equal to reaction RA minus the load that will be acting for this much distance at till 1 meter distance. So load at 1 meter distance, right? So load at 1 meter distance. So how do we find? We first need to find reaction RA here. So we need to find RA, RB. Now how do we find reactions? To find reaction, it is RA plus RB will be equal to 20 into 8, right? So from here you get 20 into 8 is equals to 160 kilonewton. Now by making summation of moment about A equals to 0, I'm taking from this point. Okay, so if I take it from this point, I have RA into 0. This force towards A will go clockwise direction, so plus 20 into 8 by 2, right? Then RB reaction, which will go anti-clockwise direction, minus RB into total distance from B to A is 8 meters, equals to 0. I'll get this. Now if I cancel this here, it will be 4, right? So if I multiply all these values, I'll be getting 640 will be equal to, if I send this RB into 8 to right hand side direction, it will be positive, so it will be 8 RB. So from here RB will be equal to 640 divided by 8, it will come equal to 80 kilonewton. Now from here RA will be equal to, from this equation here, 160 minus 80, which is equals to 80 kilonewton. This is how we found reaction in unit number 4, right? So now there is another way you can find reaction by directly putting it in a formula. You found 80 kilonewton here, right? So the other method you can find reaction is by RA is equal to, directly if I put it in a formula, WL by 2. Now how much is W? W is equal to 20 kilonewton per meter. So I have 20 into, what is the length of this beam? 8 meter. 8 divided by 2. So from here if you solve this, you get exactly 80 kilonewton. So you can either solve the long way. If you don't remember this formula, you solve it like we found reactions in unit number 4. Otherwise, if you remember this formula for this simply supported beam, this formula is not applicable to all the other conditions of simply supported beam. अगर simply supported beam पे point load आ रहा है तो उस पे ये फॉर्मूला विल नॉट बी एप्लीकेबल. ओके, यहाँ पर ये सिंपली सपोर्टेड बीम है और ये सिंपली सपोर्टेड बीम पूरा स्पैन पे यूडीएल लग रहा है. तो अगर ऐसा कंडीशन है तो यू कैन डायरेक्टली यूज दिस फॉर्मूला. ओके, सो नाउ लेट्स फाइंड द shear force. So shear force S will be equal to reaction we got 80 minus load at 1 meter distance will be equal to 20. इंटेंसिटी इसका यहाँ पर यूरियल जो लग रहा है ये भी 20 होगा और इनटू उसका डिस्टेंस 1 मीटर तक ही करना है. सो इनटू 1, राइट? सो 80 minus 20 you get 60 kilonewton. So this is the shear force. Now if you want to convert this kilonewton to newton, it will be 60 into 10 raised to power 3 newton. So this is the shear force. Now we found the shear force. Now let's find Q average. So Q average will be equal to S by A, shear force by area. So shear force is 60 into 10 raised to power 3 divided by area. Area will be 230 into 350. So from here you get 0.74 Newton per mm square. This is the average shear stress. Now let's find the maximum shear stress. So Q max will be equal to 1.5 times Q average, right? So how much is this? 1.5 into 0.74. From here you will get equal to 1.12 Newton per mm square. So now let us draw the shear stress distribution diagram. We are asked to draw the we are not asked, but we can also draw the shear stress distribution diagram. Okay, it is very simple. Draw a straight line and then a parabola. maximum will be here at this point where the neutral axis is passing, and then it will go in this manner. So you have here, you have Q max, which is equal to 1.12 Newton per mm square. Okay, so this is the shear stress distribution diagram in Newton per mm square. So I hope this numerical is also clear. Let us solve the third numerical. A rectangular section having dimensions of 100 mm into 200 mm is subjected to a shear force of 50 kN. Determine the shear stresses induced on a layer 50 mm above neutral axis, and at neutral axis sketch the shear stress distribution diagram and calculate average shear stress. तो यहाँ से हमें पहले diagram draw करना पड़ेगा, उसके बाद we need to get going. So let us see how we can solve this numerical also. Let us solve the third numerical. Now in this third numerical, let us first compile the given data. So given, we have first the rectangular section is given. Rectangular section is given 100 mm into 200 mm is given, right? Then shear force is given. Shear force S is given 50 kilonewton, which we convert in, if we convert it into Newton, it will be 50 into 10 raised to power 3 Newton, right? Now what are we asked to find? First we are asked to find shear stress induced. Shear stress is denoted by Q. Shear stress induced on a layer 50 mm above neutral axis. So shear stress at 50 mm above neutral axis. First we have to find this. Second we need to find shear stress at neutral axis, right? And third one, we have to draw shear stress distribution diagram. Right? And the fourth one, we need to find Q average, right? Now from this given, let us first draw the section. Section is given. So it is given 100 mm into its depth is given 200 mm. So this section is given, right? So for this section, let us say that neutral axis is passing from here, and first we need to find see, now I'm going to divide, okay? The total depth is 200. This kind of section is a symmetrical section. So from here to here, it will be 100 mm, half, right? Now from this neutral axis above this line, it will be 100. Now above this neutral axis line, at 50 mm above this neutral axis, so let us say around here, so around here at this point we need to find shear stress at this point. So let me name this point as P point here and this point as Q point. Okay, so we need to find shear stress at this point. So I'll say this much is 50 mm and the remaining is 50 mm. So the total becomes 100. Okay, so let us first find shear force at this point, 50 mm above this point. So how will we find? It will be equal to shear force at 50 mm above the neutral axis, can also be written as shear force at, I have given this line, named this line as PQ. So shear force at PQ will be equal to the formula shear force into area into y bar divided by I into B. So this is the formula. This is a general formula, but right now I'm particularly finding at 50 mm above the neutral axis. So how do we find? Shear force given is 50 into 10 raised to power 3. So 50 into 10 raised to power 3. This is my shear force. What will be the area? Area of this section is not 200, I'm sorry. We need to take area of this much section only, this much only. सिर्फ इतना का ही एरिया लेना पड़ेगा. तो कितना होगा? यहाँ से यहाँ तक इट इज़ 100. सो आई हैव 100 इंटू, और उसका ये डेप्थ इज 50. सो 100 इंटू 50 प्लस वाई बार इज द डिस्टेंस, राइट. जो इसका हम न्यूट्रल एक्सिस से इसका जब डिस्टेंस लेते हैं, सो वी नीड टू कम फ्रॉम द टॉप. ओके, सो ये हम ये एक्सिस के ऊपर से टॉप से आया तो न्यूट्रल एक्सिस तक. What I'm saying is I need to come all the way from this top portion till this neutral axis line, यहाँ तक, till neutral axis I need to come. So from here to here I have 50 plus I have this 50. Now ये section का आधा पे लेना चाहिए, half, सिर्फ इतना ही लेना पड़ेगा. So this will be 50 divided by 2. This is y bar. Okay, divided by, now what is I? I is moment of inertia. Moment of inertia, I is equals to BD cube by 12, right. अब यहाँ पर B कितना है इसका? इसका B is 100 into D कितना है? D पूरा का लेके जाना पड़ेगा. D is 200 cube divided by 12. अब ये पूरा सेक्शन के लेके जा रहे हैं, ये पूरा सेक्शन के, into how much is B? B is from here to here 100. So if you solve this, you will be getting shear force equal to 2.8125 Newton per mm square. So this is the shear stress at 50 mm above the neutral axis. Now similarly we are asked to find force at neutral axis, right? So how do we find? Shear stress at neutral axis will be, shear stress at neutral axis will be again the same formula use होगा, SA y bar by I into B. Now यहाँ से force will remain same, okay, which is 50 into 10 raised to power 3 into area. अब यहाँ पर neutral axis तक, right, till this point. So I can take this box, I can either take this box, or I can either take the box above this neutral axis or the box below the neutral axis. So I'll take, for now, for convenience, I'll take box below this neutral axis, right. So what is the area of this box? Area of this box is 100 into 100. B and उसका depth 100 है till neutral axis तक. So area is 100 into 100. Now y bar कितना होगा? इसका आधा इतना होगा y bar, right. So how much is this? This is 100 divided by 2 divided by ये सेम रहेंगे 100 into 200 cube divided by 12 into 100. So from here you will be getting shear stress equal to 3.75 Newton per mm square. Okay, now if we draw the diagram, from here you will get a parabola, maximum at this point, then again it will start reducing. Now at this point was shear stress at 50, right? This we got equal to 2.8125 Newton per mm square. We got this much, and at this point, where this point is a point where you will have a maximum shear stress. So this is a shear stress at neutral axis. We got equal to 3.75 Newton per mm square, and this is a shear stress distribution diagram. Okay, so I hope this numerical is clear. Coming to the fourth numerical for this session, we have the statement as a beam section 100 mm into 200 mm is subjected to a shear force of 60 kilonewton. Determine the shear stresses induced on a layer at 50 mm above neutral axis and 25 mm below the neutral axis. So यहाँ पर particular point दिया है, वहाँ पर हमें particularly those layers we need to find shear stresses induced. So let us see how we can find the shear stresses at those particular layers. So let us get started. Let's solve the fourth numerical. Now for this fourth numerical, a beam section is given, right? So let me directly draw. Beam section is given 100 mm into 200 mm. Okay, so this is 100 mm. And its depth is 200 mm. And what else is given? It says it is subjected to a shear force of S is given equal to 60 kilonewton. Now if you convert this to Newton, it will be 60 into 10 raised to power 3 Newton, right? Need to determine shear stress induced on a layer. First one, we need to find shear stress at 50 mm above the neutral axis, and second one, we need to find shear stress at 25 mm below the neutral axis. Okay, so how do we find here? So this is a symmetrical section. So for symmetrical section, we'll have something like this, right? Neutral axis will go right from the middle. So from here to here we have 100 mm, and the other half from here to here it will be 100. Right, now we are asked to find first shear stress at 50 mm above the neutral axis. So this is the neutral axis. Now above this neutral axis at 50 mm, so at this point, okay, which is from here to here, it is 50 mm, and from here to here it is 50 mm. So total becomes 100. So let me name this point here again as P and Q point. So we need to find shear stress at this point 1. Next, they have asked us to find shear stress 25 mm below the neutral axis. Neutral axis is here. Now below this neutral axis, below it is going 25 mm. Okay, so this distance here is 25 mm, right? So what will be the remaining distance from here to here? It will be 75 mm. Okay, so let me name this point as RS point. So we need to find shear force at PQ and RS point. So let us see how we can find. If we find shear force at 50, which is equal to shear stress at 50 will be equal to shear stress at PQ will be equal to SA y bar by IB. This is the formula. How much is shear force given? It is given equal to 60 into 10 raised to power 3 into area of this section. Now we just need to see area of this section, this much only, this much only. So how much will it be? B is 100, depth is 50, so 100 into 50. Area, what will be y bar? Y bar will be, need to come all the way from this point till neutral axis, right? So from here to here I have 50 plus, now for this section I need to find half, at half only. This will be at this point only, from here to here. Okay, from here to here, and from here to here is 50. Then when you reach here it will be half only, half of this section, which is 50 divided by 2. Okay, divided by I will be BD cube by 12. So how much is B? You need to see for the total whole section. Now B here is 100 into D is 200 cube by 12 into B is 100. So from here you get 3.375 Newton per mm square. So this is the shear stress at 50 mm above the neutral axis. Now if we find shear stress at this point, RS, so shear stress at 25, or you can also say shear stress at RS point. So the formula remains same, y bar by IB. Okay, so from here it will be equal to, S is 60 into 10 raised to power 3 shear force into area. Now area, need to take area of this section, which will be this box, this much box. Okay, it is below the neutral axis at 25 mm, so we have this much. So what is the area of this much box? It is 100 into depth is 75 into y bar. Now you need to go from this base till the neutral axis, so you need to find this. For this base it will be at half, which will be 75 divided by 2 plus remaining distance till neutral axis is 25 mm, so plus 25 divided by IB, which is 100 into 200 cube divided by 12 into 100. So this, from here you will be getting equal to 4.219 Newton per mm square. So you are just asked to find the shear stresses at these 2 points. They have not asked for the shear stress distribution diagram. Numerical is over till here only. Okay, so I hope this numerical is also clear. This is the last numerical for today's session. So it says a beam of rectangular cross section 200 mm into 300 mm. It is subjected to shear force of 48 kilonewton. Calculate shear stress at top layer and at distance of 50 mm, 100 mm and 150 mm from the top layer. Draw shear stress distribution. So now यहाँ पर भी एक particular place दिया है, particular layer दिया है, right? A distance has been given. So at that particular distance from the top layer, we need to find the shear stresses and then draw its diagram. So let us get going. This is the last numerical for today's session. So for this, a rectangular beam cross section is given. So let me draw the diagram here. So the dimension of this cross section is given equal to 200 mm and its depth is given equal to 300 mm, right? And what else is given? It is subjected to a shear force of 48 kilonewton. So shear force is given. Shear force S is given 48 kilonewton, which if we convert it into Newton, it will be 48 into 10 raised to the power 3 Newton, right? What else is given? Calculate the shear stress at top layer and at a distance of 50 mm. So we need to find the shear stress at this top layer. So if I draw the neutral axis here, neutral axis will run something like this, right? And I need to find shear stress at this top layer. So this is the top layer, right? Let me name this as A, B, top layer AB, okay? And next we need to find shear stress at top layer and at a distance of 50 mm, 100 mm and 150 mm from the top layer. So from this distance at 50 mm, so total distance is 300, so half this distance will be 150 mm, right? Now what will be if we divide it, the stresses at which we have to find from top layer at 50. So we need to find one at 50. So I'll mark it here at 50 mm. Then next we need to find it at 100. So from here to here, let me mark it as another 50 mm. So this total will be 100. So I need to find another one here, and next at 150 mm from the top layer. Now from top till here it will be total, this whole total will be 150 mm, right? So I need to find it at this point 1, next here. So let me mark it here, 1 I need to find it here, right? Second here it will be Q50. So at this point from top till this layer it will be, this will be Q100, right, at 100 mm. And at this point it will be Q150 from top till the neutral axis line. So we need to find Q50, Q100 and Q150. So let us see how we can find. First, to find shear stress at Q50, for Q50 the formula will be S A y bar by I B, right? So how much is S for this top layer? S will be same, okay, 48 into 10 raised to power 3. Now what will be the area? Area will only be this much. ये 50 तक जो आया है, क्योंकि मैं 50 के लिए फाइंड कर रही हूँ, तो यहाँ तक, यहाँ से यहाँ तक गई, तो एरिया क्या होगा? एरिया इट इज 200 into what is its depth? 50, right? Into y bar. Y bar कैसे फाइंड करेंगे? Y bar will be equal to, हम यहाँ से will go from here till here, okay? So from here, यहाँ से यहाँ तक का पोर्शन कितना है? It is 100 mm, right? And from remaining from here to here it is 50. So first I'll add 100 plus, अब ये जो 50 का पॉइंट के है इसके आधा पे फाइंड करना है, तो it will be 50 divided by 2, okay? Divided by BD cube by 12 of this whole section will be, B is 200, D is 300 cube divided by 12 into B is 200. So from here you get 0.67 Newton per mm square. So you get this much, okay? Now let us find at Q100. So Q100 पे it will be equal to SA y bar by IB again. So इसके लिए S will remain same, which is 48 into 10 raised to power 3 into area. अब area कितना होगा? Area will be 100 into 200, right? क्योंकि हम ये टॉप लेयर से आ रहे, टॉप लेयर से आया तो ये इतना बॉक्स आपको कंसिडर करना पड़ेगा. तो ये कितना है? इट इज, उसका डेप्थ इज 100, width is 200, 100 into 200 into, अब यहाँ से यहाँ तक का डिस्टेंस कितना है? 50, और यहाँ से यहाँ तक 100, so total becomes 150, right? So यहाँ से यहाँ तक का 50, so add this 50 here, 50 plus, अब ये 100 का जो ये पूरा सेक्शन का है 100 का आधा लेना पड़ेगा, so it will be 100 divided by 2 divided by 200 into 300 cube divided by 12 plus 200. So from here you will get Q100 will come equal to 1.067 Newton per mm square. Okay, so this will be the shear stress at 100. Now let's find shear stress at 150 will be equal to SA y bar by IB. Now यहाँ से S कितना होगा? S will remain same, which is 48 into 10 raised to power 3. एरिया कितना होगा? अब एरिया ये पूरा बॉक्स का होगा, यहाँ से 150 पूरा आया था ना, ये बॉक्स का पूरा का होगा, तो कितना होगा? ये 150 into 200 full length, right? Into y bar will be half, इसके हाफ पे आएंगे, तो कितना होगा? 150 divided by 2 divided by 200 into 300 cube divided by 12 plus 200. So from here you get Q150 equals to 1.2 Newton per mm square. और ये जो Q150 है, it is right at the neutral axis, so इस पे maximum आएंगे. So we got maximum from the three of the values, we got maximum at 150, which is at neutral axis. Now the next we are asked to find shear stress at this top layer. So shear stress at this top layer will be equal to 0. Why 0? Because area here, because यहाँ इसका ये टॉप पे ही है, तो एरिया कैसे लेंगे हम, राइट? वी ओनली हैव बी, डेप्थ तो है ही नहीं, तो एरिया विल बी इक्वल टू 200 into, it is at this point only, at the top layer, so 200 into 0, it will be 0, right? So that's why at top layer shear stress will be equal to 0. Okay, now if you draw the shear stress distribution diagram, यहाँ से ऐसे आएंगे, मैक्सिमम होंगे यहाँ पर, उसके बाद it will reduce. Okay, so here at this point, here you have Q50 equals to 0.67 Newton per mm square, and then at this point, which is Q100 is equals to 1.067 Newton per mm square, right? 1.067 आया, और ये पॉइंट पे which is at neutral axis, which is Q150, मैक्सिमम आते हैं यहाँ पर कितना आया, 1.2 Newton per mm square, और this is your shear stress variation, और नहीं तो distribution diagram. Okay, so I hope this is clear. I'll see you in next session with more numerical.